Madam.
Good evening to one and all. It gives me immense pleasure to welcome you all to this insightful session, third session on carbon footprint, lifestyle assessment, and ESG metrics. On behalf of the SCSVMV and organizing team, I extend a warm welcome and introduce our distinguished speaker, Dr. M. Suresh Gandhi, Chairman of School of Earth and Atmospheric Sciences, Professor and Head of the Department of Geology, and Head in charge of the Center of Environmental Science and Applied Geology, University of Madras. He has also served as a nodal officer of IUINDRR, National Institute of Disaster Management, and RUSA 2.0, Team 3 Coordinator. Dr. Gandhi is a distinguished academician and researcher with decades of experience in the fields of geology, environmental science, and disaster risk reduction. His multifaceted expertise spans from sustainability studies to applied geology, making him one of the most respected voice in earth and environmental science today. Through his leadership roles as chairman of the School of Earth and Atmospheric Sciences, professor and head of geology, and a nodal officer for IUINDRR, NIDM, Dr. Gandhi has made significant contributions to advancing research, policy, and academic initiatives is in sustainability and disaster management. Today, he will guide us through critical themes such as understanding carbon footprints, applying lifestyle assessments, and integrating ESG metrics, tools that are indispensable in addressing climate change and fostering sustainable development. We eagerly look forward to learning from his rich expertise and gaining perspectives that will help us as scholars, researchers, and global citizens. Now, the session is yours, sir. Please.
Thank you, madam. My slide is visible.
Yes, sir, it's
Okay,
visible. Yes.
okay. Thank you. So first of all, I thank Dr. Lakshmi Bai, madam, SCSVMV University, and all other organizers of this event for nicely conducting this program. In fact, today is the final day of this program. So you are all eagerly waiting to close the system and go to the home. And okay, so I am Professor Suresh Gandhi from geology background, and I think so more than 7 days you have learned well expertised in all aspects in environmental related studies. So here they gave topic for me on carbon footprint, life cycle assessment, and ESG metrics. Okay, I will start my lecture. 1 minute. Second slide moving. Slide
Yes,
moving,
sir.
madam.
Yes, sir.
Okay.
Yes.
Yeah. So we are all flying now, flying from New York to London and back. So that means we release approximately 1.7 metric tons of CO2 equivalents per passenger. So that nearly equivalent to what some people in developing countries emit in the entire year. So, and again, one more example. Nowadays, we are all using t-shirts, no? So producing the single cotton t-shirts uses 2,700 liters of water and emits about 2 to 3 kgs of CO2, depending upon the materials, manufacturing practices, and transportation distances. So, what do you mean by carbon footprints? So, we are all always talking about carbon footprint, no? So, carbon footprint is the total amount of greenhouse gas emission that come from the protections, uses, and the end of life of a product or services. Here it includes mainly carbon dioxides. So that means the gas most commonly emitted by the humans and all others, including the methane gas, nitrous oxides, fluorinated gases, and the trap heat in the atmosphere, this is only we have the global warming will be caused. So the greenhouse gases like carbon, carbon dioxide, methane, they emitted through the burning of the fossil fuels, and also land clearances for protections of the food, industrial emissions, manufacture of goods, infrastructure developments like that. So the bulk developments of an individual carbon footprint will come from the transportations, housings, and also through the food. Here you can see the carbon footprint level for different sectors. For agriculture, 15%, road and transport, 15%, industries, 20%, and building, 6.4%. So like that here. Then what actual definition for the carbon footprint? Again, carbon footprint is the total greenhouse gases emissions caused directly or indirectly by the organization or individuals or event or product. And finally, it is expressed as the CO2 equivalent emissions. So this can be measured as a CO2 equivalence, CO2e. Again, there is a direct emission is there, and indirect emission is also there. So direct emission means fuel. We all are using nowadays no fuel. Without fuel, we cannot live. So everybody having their own houses, 2, 3, 4 bikes and cars, vehicles, everything. No, so burning of the fossil fuels from the vehicles and also industrial purposes. These are all comes from the direct emission of carbon dioxide. Again, if you go for indirect emissions like electricity uses, supply the chain product uses, and also disposals like that. Main sources: energy use, transportation, industries, agricultures, and also the waste. So the carbon footprints helps to identify the hotspots for the emission reductions. How can we calculate the carbon footprint? Means by active data into emission factor. Suppose driving a car, that means carbon dioxide from fuel combustions, and using electricity, there are also emission from power plants. Then buying products, that means emission from productions, packing, and then the transportation, everything. Before that, this is all the basic things you have to already know, but again, I have to repeat it. So greenhouse gases, mainly carbon dioxide is the first comes. That is the heaviest greenhouse gas emitted in the atmosphere through the human activities, and this only the major contributes for the climate change. Why? Because it has remained for the long time in the atmosphere. So sources, main source like deforestation, fossil fuel combustion, and also industrial processes. Then next to carbon dioxide, we are all facing the problem with the methane. So a compressed of compared to the carbon dioxide, methane is also much more efficient and also comes to trapping the heat, but it remains for the short time, and it contributes significantly to the near-term warnings. So methane source through the agriculture, fossil fuel extraction, and also by the landfills. This all of you know. Followed by nitrous oxide. This is also one of the strongest greenhouse gas. It has a long-lasting impact on the environment. So it has a lifespan time of 114 years, and it also plays the role in the depletion of the ozone layer, and it is also uh, sourced by combustion, agriculture, and also industrial activities. And next greenhouse gas is the hydrofluorocarbon, and these are all the synthetic gas. Uh, Also the global warming potential, high global warming potentials, and it is also emitted in smaller proportions as compared to carbon dioxide. Uh, Here the this GHG gases, they do not deplete the ozone layer. Here this one, but main source for the hydrofluorocarbon through our refrigerator, air conditioner, like that. So perfluorocarbons, and this is steady gases with a lifetime to over thousands of years, and they have a high global warming potentials, and also They are remarkably to long-term warning, like source aluminum productions and semiconductor manufacturings like that. And again, there is three steps in the carbon emissions scopes. Three scopes we have categorized. They have categorized for the different types of greenhouse gas emissions that was created by the company, by the suppliers, by the customers like that. First one is a direct emission. That means uh, the emission that is owned or controlled by the companies, like main sources, they control directly, like burning the fuel in the company's fleets or vehicles, like that. And then emissions, indirect emissions, second type of scope, that is indirect emissions by generation of electricity and through the building activities like that. And third, again, also that is one more indirect emission through the customers, like they are coming under the chain activities. So whatever we have consumed by company buys, uses, and disposes the products from the suppliers, that is comes under the third category. Similarly, here the carbon footprints from the scope 1, scope 2, scope 3. Here first emitted, generating the emitted, like gas heating, fossil fuel oil, they have burned through the industries, and refrigerant losses from air conditioned fridges, and also emissions from the manufacturings. These are all the comes under the scopes. So beginners, and then electricity purchased from the energy, electricity from electric vehicles, and also steam heat or cooling like that. And finally, that indirect emissions, so whatever the services you purchase, goods and other things, distribution uses of the goods, waste disposals, and travels like that. As far as some data, who are all the more contributor about for the who has the biggest carbon footprint? Here you can see the uh, China. They have more polluters, carbon dioxides. For example, 10,065 million tons, followed by United States and India also in that list, and Russia, Japan, Germany, and Iran. See the same diagram, pie chart diagram. Here we can see here percentage wise they are given a carbon footprint level. Actually, you have to calculate the carbon footprints that through the direct carbon emission and also by the indirect carbon emissions. So direct already know directly from the site, and indirect means whether carbon emissions from the sources of whether in the upstream or in the downstream process like that. Here upstream means like transportation of materials, energy used outside the production facility, and waste produced outside for the production facilities like that. And downstream means the end of life processes, product of waste transportation emissions like that. So here the carbon footprint is measure of a total greenhouse gases emission resulting from human activities such as burning fossil fuels for energy, industrial processes, and also the deforestations. So it is typically measured in units of carbon dioxide equivalents. And also it includes emissions from the transportation, energy use, and waste disposal, industrial processes. So like that, finally, all this carbon dioxide create environmental issues, environmental impacts, and also followed by the climate changes. Yeah. Yeah. What makes up your carbon footprint? Here we can see through the food waste, then energy, how you source energy like solar, or how the energy efficient your home is, how much energy you can use like that. And suppose we are all using transport, no, if you have a bike, walk, use public transports, and even a flying or car like that. So transport through transports and waste products. by composting, recycling, avoiding waste like that, and through the water sources, how much of water we can use to wasted in the garden and run in kitchen, all other like that. So these are all finally makes up for a carbon footprints. Again, these are all one more examples. Like United States, the average annual carbon footprint for the individual living, they have 16 metric tons for their individual livings. Similarly, in the Texas, USA, they have average annual carbon footprint is 24 metric tons, like that. So if individual means we have a less carbon dioxide emissions. If you have a more and more increasing family household, we have a more carbon dioxide emissions. Okay, this I will skip it. Yeah, this is carbon. Again, there are various method to reduce the carbon footprints. Renewable, a lot of methods nowadays we are all following, like various technologies from the energy sector, industry sector, agriculture sector, and also transportation sectors to facilitate the energy efficiency. And we are all switching to the renewable sources of energy, and also like transport, we have changing the transport, changing the lifestyles. Already government insisted no 3 or 4 or 5 hours are also there. Reduce, reuse, recycles the waste. And the carbon sink, all of you know, ocean is the major carbon sink, nowadays. The then how much carbon sink is there, how much carbon emitted, everything we have to make it nowadays. So there are actually we have the 9 steps to reduce their carbon footprint, like less energy use, alternate travel, plant-based diets, reduced waste, eco-friendly systems, reduce the water usage, renewable energy, began to reusable the containers, plant more trees. Finally, we are talking no. So these are all the various methods to reduce the carbon footprints. And there is a relation versus carbon versus ecological footprint also. And there is also, yeah, carbon neutrality and net zero. Once you reduced carbon footprint, no, we can go up to the net zero values. So that means neutral. We have to reduce the carbon dioxide emission. Carbon neutrality means to remove the equivalent amount of carbon dioxide emitted through the activities across the supply chains by investigating in the carbon sinks that absorb the carbon dioxide. Here, ocean is the major sink for the carbon dioxide sinks. So, Kyoto Protocol, all of you know, the Paris Agreement, and 2015, carbon neutrality is one of they have achieved. They have planned to achieve up to 2050 to mitigate the effect of climate change. Okay, so they have to go for net zero values. That means beyond the removal of just carbon emission. So net zero refers to all greenhouse gases being emitted in the atmosphere, like they have to reduce methane, nitrous oxide, and hydrofluorocarbons. So carbon neutrality, and to reach net zero, the greenhouse emitted in the atmosphere must be equivalent to the greenhouse gases being removed from the atmosphere. So whatever we're releasing as a greenhouse gases, we have to remove from the atmosphere. We go for the net zero values, and then only for that nowadays people are talking about the carbon credits. Yeah, carbon credit is a generic term for any tradable certificates or permit representing the right to emit a set amount of carbon dioxide or equal amount of different greenhouse gases. So one credit permit the emission of 1 ton of carbon dioxide or equivalent in another or other greenhouse gases. Okay. Uh, so here nowadays carbon credit certificates, most of the companies they are generating. No, the credits awarded to industries decreases with time. They're promoting the industries to adopt to method that result in lesser carbon emissions. And what we geology mainly talk about on carbon dioxide emission, what happened in the past, what will we go in the future. So why sustainability matters, we have talked in geology. uh, I think the most of the participants are non-geologists, isn't it? All are few non-geologists, different engineering aspect, I think. Is it correct? Participants, all are any geology background peoples are here? May I audible, madam? All are geology or non-geology participants? Anybody can answer. Okay, shall I continue? Shall I continue?
Yes, sir. Sir,
Okay.
they are
Yeah.
responding
Yes,
on the
sir.
chat, sir, actually.
Oh, chat. Oh, not. They are all muted. No, that's
Yeah,
why
they're all
they are not.
muted. Yes,
Okay,
that's
okay,
correct.
okay,
At
okay.
the
So
end, they will ask, sir.
Okay, okay, okay. So now I
yeah.
want to know about the participants, whether they are in geology background or general other engineering background like that. No, okay,
So most
All
of them
are
are non-geology, but
okay,
there seems to be maybe a couple of people are from geology.
okay, no issues, sir. Okay,
Yeah.
yeah. Here, geology directly influences the natural resources extraction and also the ecosystem stability. It make it critical to understand the sustainable practices. So that's why sustainable development goal, all of you know the 14 sustainable goal, made that ensure the earth resources and preserve for the future generations. And here in SGDs, one of the carbon footprint, also the cleaning carbon, that is comes under this SGDs. So here carbon footprint, already you know that the total greenhouse gas emission, it can cost both directly and indirectly by an activity or product, and it is expressed in carbon dioxide equivalents, and which is standardized various greenhouse gases as based on global warming potentials. So once we reduce the carbon footprint, and if you're not done that emission of carbon dioxide, finally we may cause problem with the climate change. So all of you, we are all targeted to mitigate the climate change. So for that, we have to understand the carbon footprint levels and how we have to reduce the carbon footprint. Okay, yeah. Here geology, what is the role in carbon emission? Here generally what earth science, all of you know. uh, Here geology, we are not studying only about the earth, so we have to concentrate on the mineral resources. So that means mining sectors. So wherever we go, entire coastal area, we have a heavy minerals. That means beach placer minerals also there. So we are extracted the heavy minerals along the beach side, and we have to transport it. We have to export it to other foreign countries. For example, in Tamil Nadu, all of you know, near Tamil Nadu, Kanyakumari coast, we have a Manavala Kurchi. So have you visited? I don't know how many of you visited Manavala Kurchi in Kanyakumari. If you go and see the beach, there you can see black color sand. Sand color is different. While if you're coming to Kanyakumari coast, you have to see red color sand. Again, if you go to the Karaikal beach, you have to see the again dark color sand is there. Then again, if you go to while coming up from Pondicherry to Chennai, there you can see the white color sand. So the sand itself, you have a different colors that indicates different types of heavy minerals distributed along the beaches. So red color means garnet. So garnet is one type of mineral, abrasive minerals. So that can be used in the pigment as the paint. So we are traveling the flight now, so it is not corroded. So for the pigmenting agent, corrosive, for prevent the corrosive nature, they are adding this minerals like garnet, and also similarly other heavy minerals also there, rutile, tourmaline, zircon. Here I told no Manavala Kurchi, black color, that is a monazite. Monazite mineral is there. And if you see the red color means garnet. Again, black color means ilmenite mineral is there. Again, if you see the white color means that is quartz sand is there. So whatever nowadays we are using, no glasses, lenses, all items coming from the quartz silica sand only. So geology itself, we are mining, extractive activities, mainly mining and drilling. So there we released the carbon dioxide, not geology. Whenever or who want to construct a house, or we want to anything, any building, so we have to dig the earth. No, once you touch the earth, we have to emit. We have to start emit the carbon dioxide. So extractive activities such as mining and drilling, that releases the carbon greenhouse gases, and machinery operations, land disturbance, whatever we did in the land, no, initially started, the carbon dioxide level will be changed. And then transporting the raw materials, it involves the heavy fossil fuel required. So fossil fuel combustions, that is amplifying the carbon footprint. So geological process can also aid the carbon sequestrations through the natural carbon sinks, and also through engineering solutions and balanced emissions over the time. And yeah, this already explained here. And in my topic, that life cycle assessment related to carbon footprint, yet evaluate the environmental impacts of the product or processes throughout the entire lifespan, from the raw material extractions to disposals. So by considering the every phases, this lifestyle assessment identified the major hotspots. Wherever the more significant environmental burdens occur, it enabling the sustainability improvements. Okay, so the comprehensive approach helps avoiding the shifting impact from one lifestyle stage to another, and also ensuring the environmental benefits. And so that the life cycle assessment is the systematic methodology that is used to evaluate the environmental impacts of the product, and also processes and surface, and the service across its entire life cycles. That means extraction of raw materials to the productions, and then distribution, and then usage, and end of life disposals, and finally recycling. So that impact we called as cradle to grave. Actually, we called as cradle to grave. Okay, and actually, this international organization for standardization, ISO, is there, no 140/44 and ISO 140/67. They provide guidelines for conducting the life cycle assessment, and yeah, they have a the methodology to assess the environmental impact across all stages of the products, and they have a raw material extraction, and then manufacturing, distribution, uses, end life. I told no that one, and it provides the holistic view of environmental performance like that. And here there is four main phases are there. Yeah, this life cycle assessment is a standardized methodology for evaluating the environmental impacts, reduce the uses of product, or service throughout its entire life cycle from raw material acquisition to disposals. So from beginning to ending, like that. I told no 4 main phases. First one is called the goal and scope. Goal and scope. That means identifying the purposes, some system boundaries, functional unit, like one plastic bottle or 1 kilometer of vehicle travel. So like that. Okay, that is a goal and the scope. And then second phase is inventory analysis. Inventory analysis is there. It compiles the data on input like energy, materials, and output like emission and waste throughout the system. And impact assessment is also there. ICIA impact assessments is there. And the impact assessment, that means that translates the inventory data into potential environmental impacts like global warming potential, ozone depletions, acidification, eutrophication, human toxicity. So like that, the impact assessment is there. That is in the third phase of LCA. And finally, the fourth stage is called interpretation. Interpretation means we have drawing some conclusions, we have to making recommendations, and we have to identifying the trade-offs to improve the sustainabilities. And that is a decision, improve process, communicate our findings effectively. So like that, we have a 4 phases of life cycle assessments. Yeah. Again, we different approaches in the life cycle assessment, like process-based life cycle assessment, input-output based life cycle assessment, and also hybrid life cycle assessments is there. Yeah, this already I told, no? Yeah, this is that 4 phases I told, no? First phase, that is goal and scope. 1 plastic bottle or 1 kilometer of vehicle travel, so like that. And impact assessment also I told, no, like that the inventory data into potential environmental impacts. Whatever we have to find out, no, like climate change, global warming, eutrophication, ocean depletion, acidification, water depletion, human toxicities, like that. And finally, the interpretation. So that is same here. I have given here phase 1, phase 2, phase 3, and phase 4. So here phase 1, identify the largest potent points of environmental impacts, reduce the total carbon footprint of the product, reduce the shipping and distribution impacts, like that. Phase 2 means mainly data collections focused on the product inputs. Phase 3 are the assessments. After the data collections, we have to get assessed. Final one is phase 4. Yeah, this comparison of LCF plastics and paper bags. Here, plastic generally what happen? Lower production energy, higher waste issues. Whereas paper bag having the higher production energy, but reusable and recyclables. In our topic, again, there is an environmental social governance also there. That is called ESG, environmental social governance. What do you mean by environmental social governance? It and its metrics. It provides the framework for helping a business ensure it invest in improving the lives of its employees, customers, and also a wider community. So by looking into the culture within the company and communicating to work towards higher standards, mainly in 3 areas. One is a sustainable goals, and we have to look after the people and communities, and finally the responsibility and professionally. So ESGs can make differences. Environmental social governance. Here, environmental mainly comes under the carbon footprint, water use, waste management, and again, they increasingly important for investors, for companies, for regulators and stockholders, everything. Social comes under the labor rights, diversity, community impact, and governance, mainly on ethics, compliance, transparency, everything inside. So these are all the three pillars: environmental, social, and governance, who are their energy usage and efficiencies, climate change and strategy, and waste reductions, biodiversity losses, greenhouse gas emission, carbon footprint reductions. So we have to follow in this case for environmental. In case of social, we have concentrate on fair pay and living wages, equal employment opportunities, employee benefits, workplace community engagements like that. And in governance, we have a corporate governance, risk management, ethical activities, avoiding the conflict of interest, integrity, accounting integrity and transparency like that. So there's all three having the so this environmental social governance are set of standards. That means they used to evaluate company sustainability and also the ethical performance beyond the traditional financing reporting. And investors, regulators, stockholders, they are all increasingly rely on this environmental social governance. Why? Because to assess the long-term risk, resilience, and also value creations. And here there is an integration of carbon footprint, quantify the greenhouse gas emission. Then we have to provide the measurable indicators for the climate impact. In life cycle assessment, we have evaluate the environmental impact across the entire products of life cycle. Then we have to generate the detailed data for that. And the ESG metrics, that is a broader framework, including the environmental, social, governance, performance. And finally, this life cycle assessment and this carbon footprint data that gives for sustainable reporting and compliance. So that means all are integrated: carbon footprint, life cycle assessment, and everything. And yeah, this way here you can see the integration of carbon footprint, LCA, and ESG like that. So various applications also there. Yeah, this already told. No, oh yeah. And now I have to go something related to carbon dioxide. What happened? You have to know something. We are all talking carbon dioxide emission, carbon dioxide emission. What the real fact? What you know about geology? Oh, how many of you know the age of Earth? Everything happened in the Earth only, no? So for that you have to know about the age of Earth. And I think somebody maybe reply in the chat box. If anybody know the age of Earth, what is our age of Earth? So we are all, if you call what is your age, means we are telling my age is 25, 30, 35 like that. No. What is the age of Earth? Anybody knows that? So approximately you tell the answer. Even in the chat box, you can tell the answer. What is the age of Earth? How many of you know? Okay, I don't want to waste the time. 4.6 billion years. Okay, 4.6 billion years ago, our Earth was formed. And now we are living in the recent ages. Okay, recent age. That means up to 4.5 billion years to recent what happened in the Earth. That means there is a time, some time framework is there. So here we divided our geological Earth system into three different times. One is called Paleozoic, Mesozoic, and Xenozoic. So Paleozoic means earlier formed, Earth earlier formed time. So that means when Earth formed, no, there that times no life at all. Without life means we call it as Haden period, Haden, no life at all. Then only rock surface, rock formation is there. After that, only some algal development, redoxites. That's why we have now iron. Iron material is there. No, entire iron deposit all over India. So iron is there. No, and then Paleozoic period is the longest period, longest era, followed by there is a mass extinction. Mass extinction means in the Earth system there is a sudden change due to some major impact like meteoric fall down in the earth or sudden frequent volcanoes or huge change in the earth. So this is called, that means there is if you, it is happen like that, no, entire earth will be collapsed, so no life will be evolved at that time, no, that time is called mass extinction. Like that there are several mass extinction happened from the past 4.6 billion years to recent. So in between we have a three major age like Paleozoic, Mesozoic and Xenozoic. So Mesozoic, all of you know. Nowadays people watching a movie also know one movie. How many of you know that movie? I don't know. Have you seen very big animals coming on that movie? What is the name of that animal? Anybody knows that? Jurassic. The movie also named Jurassic Park. The biggest animal is dinosaur. Okay, that means Mesozoic period, shortest period. Only three period is there in the Mesozoic. That Triassic, Jurassic, Cretaceous. That means three period. So the Triassic period, the dinosaur egg will coming out, and it evolved as a very big dinosaur. And the third stage, no, Triassic, Jurassic, Cretaceous period, there is a huge meteoric impacts and huge volcanoes, iridium gas exposure. Automatically, all the dinosaurs extincted. So that period is extincted. Again, Xenozoic period evolved. So that is called recent. Now we are all living now in Xenozoic, like Eocene, Miocene, Pliocene, Pleistocene, Holocene, recent. Now we are in recent age. Okay, so that is called geological time scale. Okay, Paleozoic means Haddon, then Precambrian, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. So Carboniferous period only will get more amount of coal. Coal will be evolved during the Carboniferous. Whatever we are eating, the fish, no, that is formed in the Devonian period. And the dinosaur extincted during the Cretaceous period, that is called 63 million years ago. The entire dinosaur extincted. After that, evolution came. Reptiles, four-leg reptiles changed into the human beings. Finally, we are in two legs. So we are in recent age. So what we learn from the past, there is a fluctuation in temperature. So the carbon dioxide level not only increased now only. Whenever the earth evolved, no, from the beginning of the earth evolving itself, we are facing the carbon dioxide evaluation also. You can see here Cretaceous. I am showing the table. You can see Cretaceous. I told no, 63 million years ago, 10 degrees centigrades. The temperature is rising. That means during 1960 to 90, the average temperature somewhat above the average temperature of 1960 to 1990. That means above the in 1990, after 1990, no, that temperature is nowadays 1990 temperature. So during Cretaceous itself, 10 degrees centigrade is higher. Again, PTEM means nothing but Pliocene, Eocene. That is, these are all the age. P means Pliocene, T means thermal maxima, E means Eocene. So that is here I showed no Eocene thermal maxima, green color in the table. You can see yes, PTM. So plus 12, 12, 14. So 14 degree temperatures increased during the Earth evolved time itself. Pliocene, Eocene thermal maxima. Similarly, Eemian, this is one age, 135 and 115 kilo years. That time also 2.5 degrees centigrade temperature was increased. Then middle Holocene. Now we are all in Holocene. Now after Holocene, we are in recent age. So in Holocene period only, we have lot of sea level rise, sea level decreases, sea level increased, sea level. That means sea level fluctuation. Enormous amount of sea level fluctuation started in the Holocene period. So mid Holocene around 7 to 5 kilo years. So 1 degree centigrade temperature gradually increased. That is about the past history. Now coming to the modern climates. Again, we are all, I am telling no, Holocene, Pliocene, Pleistocene, recent, quaternary, recent. So this is before quaternary, around 2.5 million years ago. That means that time only our human evolved, human evaluation, 2.5 million years. During the Pleistocene, the temperature were generally lower than the present. Okay, there is also temperature fluctuation. Once upon a time, Earth evolved, no, the temperature will be huge. Then again, one particular period, the temperature reduced. So during Pleistocene, the temperature gradually lower than the present. There you have seen a lot of glacial, interglacial fluctuation. I told no, glacial, interglacial fluctuation. That means hot, hot, cold. No, the glacier will start melting. That's why we are calling as a glacial, interglacial melting period. And that was started since 3 million years ago. Okay. And then lot of climate changes started in the quaternary period. So recent. Now we are all in, after quaternary, we are recent age, after Holocene. Like in Antarctica temperature, if you see the Antarctica Vostok temperature, and that is a glacial, interglacial, I told no, the fluctuation. During the interglacial periods, well constrained ice core studies. What nowadays geology doing? No, we are all collecting the core sample from the seashore up to the deeper depth without undisturbed sediment samples. We collected the ice also, ice core samples in Antarctica. Then we studied the age and we study the temperature. We study all other geological parameters. No, core means core sample. So ice core samples, we identified 400 kilo years. During the 400 kilo years, there may be the 5 times there will be the cyclic changing happened. That too in the periodicity of every 100 kilo years. There was a climate change happened during the past every 100 kilo years. That is called a 5 cyclic maxima. Ice ages. One time it is a ice age and glacial, interglacial, like that. This is for 60-year cycle, very close, past 60 years. During the past 60 years also, we have a annual temperature. The temperature will be varied. Global temperature fluctuation with the periodicity of 60 years also. And the variation is plus or minus 0.25 degrees centigrade. So that means our temperature is not stable. Still, the temperature changing. Once the changing the temperature, simultaneously sea surface temperature also fluctuated. Here you can see the Atlantic oscillation, multi-decadal oscillation for the data for 1856 to 2008. So there is the variation in the sea surface temperature in Atlantic up to the periodicity of 60 to 70 years. Every 60 to 70 years, the temperature changes. So climate change has happened from the past, from the Earth beginning onwards. That is by man-made and also by the natural. Naturally, how the climate changed means main thing is orbital configuration, sun energy recipient, and also volcanic eruptions, change in reflectivity, and change in vegetation in the ice cover, meteoric impact, weathering, melting of ice, and redistribution of ocean circulation. These are all the main natural causes for the climate changes. Here, greenhouse gas. Why? Because we are talking the carbon footprint. Mainly, it is coming from the greenhouse gas only. No, so the greenhouse gas, that is responsible for the climate, changing the climate. Earlier I told no warm period, cold period. We have evidence of warm and cold periods. So during the warm event, warm means interglacial, glacial, interglacial. You can fix the term glacial. That means cold time. Cold time, nothing happened. The entire glacier will be not disturbed. In warm period, what happened? Due to heat, the glacial started the melting. So interglacial, so glacial interglacial period like that. Warm event, greenhouse gases released from the ocean and soil. Positive feedback is there. And during glacial event, the greenhouse gases return to the ocean. Okay, and again, the rise in sea level from the wetland, which increase the methane emissions, and automatically atmosphere. How atmosphere modify the climates? So atmospheric gases play the major role in modulating the radiation received from the sun. So through they are transparent to incoming energy in visible range, they absorb the heat energy. So the concentration of the major gases have lesser role when compared to the traces gases. Okay, nitrogen in atmosphere it is more 78%, and then oxygen 20%, and argon all are comes under the major gases, and the trace gases is 0.04. Again, what are the trace gases? Carbon dioxide, it is comes under the first, followed by methane, carbon monoxide, nitrous oxide, chlorofluorocarbons, and the ozone. It is good for ozone or bad for ozone? Yeah, gases. These are all the greenhouse gases. Actually, what happened? The sun radiant energy absorbed by the earth, then it converted into energy of a longer wavelength, and the visible light converted into thermal energy, and atmosphere is transparent to electromagnetic waves in visible range and absorb the thermal energy. So that is these are all of you know the concept. Here we are all talking no global warming, uh, greenhouse gases, ocean depletion, ozone. There is a good ozone mainly we have seen in the stratosphere. So below we have a troposphere, stratosphere, mesosphere, ionosphere, thermosphere. These are all of you know. So the ozone in stratosphere beneficial and help to filter the hazardous ultraviolet radiation. And if it is not means ultraviolet radiation will cause the skin cancer. So ozone is the protection layer. So that is in the higher altitude. We have a good ozone. So nowadays, what happened in the atmosphere? Ozone depletion. People are talking now. Ozone hole started. Ozone hole. The term is used for the ozone depletion. That means thinning of the layer of the ozone over the Antarctic region, particularly in the spring time, like in August and October period. Then after cold winter, the sunlight up the poles. So that is a ozone depletion. So we need a greenhouse gas. Yes, we need greenhouse gas also. Greenhouse gas is present in optimum amount to serve our uh, earth warm by trapping the solar radiation. Suppose if you don't know greenhouse means what happened? Automatically the temperature would have to be minus 18 degrees centigrade instead of present 15 degrees centigrade. So a lot of change happened. So physics people, all of you know this, and I want to slightly go with these few slides. Natural causes of climate change, how it is happened by orbital configuration. This is called the Milankovitch cycle. Simply we call this Milankovitch cycle. There is a three cyclic pattern is there. One is called eccentricity, obliquity, and precisions. So orbital configuration, what happened here? The Earth orbits around the Sun in elliptical to near central orbit. The Sun is not located in the center of the orbit, but barycenter, which is the center of mass of the Sun, as well as the planets and satellites. Larger gaseous gains have larger influence on the location of the barycenter. So the larger planets revolve around the Sun, the barycenter is dynamic and orbit also keeps changing or changing its position. Eccentricity, three types I told, no, eccentricity, obliquity, like that. Here the eccentricity varies from 0.0034 at 0.058, like that. Here the perihelion position, the Earth is closest to the Sun and apophelion is farthest from the Sun. Perihelion distance is decreasing, and that is during the January 3rd, and apophelion is distance is increasing. So that is happened in eccentricity. So that was during the eccentricity also there is an influence on climate. Here the near circular eccentricity produced the uniform climate. What happened? No, the perihelion happens in January 3rd. When the northern hemisphere experiences the winter and southern hemisphere experiences the summer. Okay, this happened during the eccentricity. And obliquity means wobbling, Earth wobbling. Also sometimes tilt, Earth tilt the axis, that means 22°.1 to 24.5. So the tilt is at higher degree. The seasons can likewise be more severe. And so the orbital precision makes the climate different changes during summer, winter, like that. And in mountain also the climate changes happen. The uplift of Himalayan mountains. No, all of you know this history. Know how Himalayas are formed? Anybody knows this history? As geology, I want to tell here. Here inside the Earth we have three different layer. One is called crust, mantle, core. Okay, 1 minute. Yeah. Inside the Earth we have a three layer: crust, mantle, and core. Crust means around 11 to 15 kilometers. Below that we have a mantle layer followed by a core layer. So what happened? No, geology we called as a plate, the crust and upper part of the mantle. So this is the lithospheric layer, rigidity in nature. So the plates are moving in different direction. So Indian plate, after a Cretaceous period, 63 million years after, the Indian plate separate. Here you have a Eurasian plate. In between you have a Tethys Sea. What happened? The Indian plate moves like your fingernail grows 6,500 kilometer. Your Indian plate moves along the Tethys Sea and hit the Eurasian plate. Here what happened? Both are continental plates. So the density, Indian plate density is low, very less density plate go down. It touches the mantle layer, and due to heavy pressure, lava, the volcanoes are emerged, the Himalayas mountains are rising. So that uplift of Himalaya mountains increase the weathering. They are the principal causes during the late Cenozoic cooling due to the drop of carbon dioxides. During the Cenozoic time, the carbon dioxide level reduced, and also increased orographic precipitation and erosion by glaciers result in breakdown of calcium-bearing silicate minerals and formation of carbonates, drawing the atmospheric carbon dioxides. These are all happened in the Himalayan mountains. And then one event, Younger Dryas event also. This is called Younger Dryas event. So this is the last 15 kilo years, 1,500 years, 15,000 years. That means called 15 kilo years. What happened? The temperature. If below you have a Younger Dryas are all colder temperature, colder period. warming is upper. You can see present temperature all nowadays increasing. Earlier, no, up to Younger Dryas event, the temperature reduced. After the Younger Dryas event, there will be you cannot see the temperature decreases. Still now, in Holocene, we also warm period. Roman, we also warm period. Medieval, we also warm period. Even ice ages, present global warming, we are facing the warm period. Similarly, ocean, there is a ocean. We have a all the waves. No, they are all hitting the coast. We are all calling as the current. No, that is not a current. Inside the ocean, no, the waves are moving inside the depth. So that is called like a conveyor belt. So the ocean current moving like a conveyor belt. So there, North Atlantic, you have a denser water. So it redistribute the excess heat from the equatorial region to temperate and also the polar region. And it becomes weak. It will cause cooling in the temperature and also polar region and warming in the equatorial and tropical region. So the ocean conveyor belt is the main causes. Nowadays, people talking on microplastic. No, I don't know how many of you working on microplastics. So microplastic, how they disintegrate. All of you telling microplastic, environmental pollution, everything. How? Why? Because this temperature is the main causes. So test temperature break down the microplastic, disintegrate into different piece of the microplastics. They are all transported via the river and accumulated in the ocean. Once it enter into the ocean, there you can see like this conveyor belt, ocean conveyor belt. All the microplastics moves easily along the conveyor belt and deposited all along the oceanic gyres. That's why Atlantic gyre, mid-oceanic gyre, Pacific gyre, you have a enormous amount of plastic debris accumulation. That is also major causes. And the climate changing, another important is called tuba eruption, tuba eruptions. Volume of eruption that happen between 2 to 3,000 kilometers in Andaman. No, there is a volcano, Sumatra, Andaman area, Indonesia here. Sumatra, Java, right? Andaman Islands. So the ash, the volcanic ash, 15 centimeter thick over the whole Asia, Indian Ocean, Arabian Sea, South China. So this tuba eruptions. It caused the cooling airborne ash, blocked the incoming solar energy, and also volcanic winter for more than 10 years. This happened. Once the airborne ash, it can spread along the overall area. No, the temperature also dropped for 3 to 5 degrees centigrade. So the Greenland ice sheets, which indicate 1,000-year period of lower oxygen isotope ratio, and due to increased dust deposition. And our human, we also the bottleneck for environmental pollutions like that. Climate change result in the near extinction of human race, reducing the population of 1,000 to 10,000 individuals. Human population, 1.2 million years, that was increased. The possible reason for reduction is due to the impact of volcanic winter of vegetation. Lot of this environmental climatic impact of mammals like East African chimpanzee, orangutan, macaque, tiger, cheetah. They are all reduction. Now, no, we cannot see anywhere. The eruption is also related to migration of modern humans out of Africa for about 70 to 50 kilo years. Simultaneously, what happened? No, sea level change happened with relation to the atmospheric carbon dioxides. And for example, if you see 2018 sea level rise up to 25 centimeter, that time our atmospheric carbon dioxide is 408 parts per million volume, whereas 1000 BP before present, 1000 years before present, the sea level was lower, minus 21 degree. That time atmospheric carbon dioxide is 280. In 50,000, 15,000 years before present, again, before younger Dryas event, 97% sea level decreased. That time also atmospheric carbon dioxide level only 200. But nowadays you can see 400 and above atmospheric carbon dioxide. So carbon dioxide, we have emitted huge amount of carbon dioxide through, for example, this one example you can see from the cement, for cement production itself, how much of fossil fuel we are using. Through the fossil fuel, how much carbon dioxide we are emitted. From 19 to 2015 data, you can see earlier only 2,000 million tons of carbon dioxide, but it goes up to 4,000 or 40,000 million tons. We are increasing the carbon dioxide level. That too, several countries through the international transport, through by China, the major producers of carbon dioxide, then Russia, Japan, everything. All the carbon dioxide, like where it goes, how we are all protected, but still we are not in safe. Where does our carbon dioxide go? Generally, what happen? Plants, soil absorb the every about third each year, and ocean surface waters about the quarter they have to observe. The rest are stay in the airborne for a long time. Okay, whatever carbon dioxide, no, it can absorb through the plant and soil and through the ocean. Remaining it may be stayed in the airborne, and 45% they are remain in the atmosphere itself. 30% absorbed by the soil, 25% absorbed in the ocean, and less than 1% only they have absorbed by the sediment and the rocks. So every time, no, we are all increasing the carbon bathtub. If you take the bathtub, ocean is the carbon bathtub. Even the current emission rate, carbon dioxide released to the atmosphere nearly twice as fast as the removed. If you remove, the bathtub will continue to fill. Okay, 350 parts per million. That means 9.1 billion metric tons every year we are releasing the carbon, but we are extracted only 5 billion metric tons. So remaining 8 million metric ton, still it is there. So that's why we are all talking about to reduce the carbon dioxide level. We have to back down to 350 parts per million, equivalent to 7.5 million metric tons of carbon, to avoid the serious climatic impacts. Suppose if it is continued, what happened? 450 ppm will be passed well before the mid-century. Okay, so so we have to reduce. We have whatever possible ways. No, we have to do that. See again one more diagram. What if you stop emission? Suppose if you stop, it will take centuries, more than a centuries, for plants and the ocean to soak up most of the human-made carbon dioxide. It will take hundreds of millions of years to removed by the rock weathering, which converted the carbon dioxide to carbonate sediments. Okay, plants and soil absorb the carbon dioxide quickly, but the reservoir will fill up fast. Okay, easily plant and soil absorb the carbon dioxide. But again, ocean, what happened? Deep ocean is very bigger, so it accesses slowly. The carbon laden water surface sink at only two places near the pole areas only it is sinking. Whereas here the sediment, what happened? Carbonate sediments are bigger and slower still. They are formed at the sea form element, weathered of rocks on land. Okay, and increase the greenhouse gases due to the human activities and natural causes. What we are all doing nowadays, no, large scale deforestation. We are cutting enormous amount of trees for synthetic agricultures and other purposes. That is not now, from 8,000 years before present. So industrial revolutions and fossil burning fuels, 18th century onwards started, and agricultural activities. This one diagram you can see here. the painting of 1565, the frozen land in Europe. So agriculture failed and resulted in people turning as hunters. They are going for hunters due to abandonment of the agriculture and increase in the forest growth. Carbon dioxide started lowering. The earth cooled, causing the little ice age. During the little ice age time, this has happened. So these are all how the carbon different gases that can be emitted in the one. Same thing, different already we have discussed. I don't want to tell again how the carbon dioxide earlier we talk about temperature. No, this is about carbon dioxide level and temperature during the past. That means past means past 20 21,000 years, 30,000 years, like that, 44 lakhs years before present. You can see the based on the ice core analysis. No, wherever the temperature increased, carbon dioxide level increased. Wherever the temperature decreased, carbon dioxide level also decreases. That is the concept. So carbon dioxide, that's why we have more concentrate on carbon footprint. So greenhouse gas is the main issue. The gas can lead to the problem. Carbon dioxide is one of the greenhouse gas. All the things together make up our carbon footprint. They are the major contributor of the carbon dioxide. And in India, carbon footprint, there are several key sectors are there in energy sectors, like coal-fired power plant, fossil fuels, transportation, and they are the major contributors. And also in industrial sectors like steel, cement, chemicals, we are all emissions. Carbon intensive. So then agricultural activities, we have methane emission, synthetic fertilizers, and deforestation, loss of forest, natural ecosystems. So there are carbon sinks. Trees are act as a carbon sinks when it is alive, but it is changing, no. So that's main thing is there. So impact of human activity. There is direct or indirect method, and then see multiple footprints. Single means not happen. Multiple footprint and their damage. And do not leave your impact here. If it is clean, leave it clean for the next user who may come here. So do not leave any footprint here. Do not leave any impact of what you did here. Do not leave your impact of having visited this place. Nobody is going to appreciate it. Leave no footprint here. So this one slide I got it from internet. And same thing, carbon dioxide increased 400 parts per million level for the past 4.1 to 4.5 million year ago. Sea level also 5 to 25 meters above the present. There is an Arctic tundra data. Okay. So carbon dioxide increased modern time. Recent also have a lot of changes. What happened if you carbon level increased or temperature increased? Another 21st century, we are all the warmest period. Coral bleaching, all of you know coral, no, coral rocks fully bleached. El Nino activities changing like that. See, 56 degrees centigrade at the death value temperature. That is the fifth warmest year. More than 62,000 people died in the summer of in the Europe. Similarly, Italy, Spain, Germany, France, UK, Greece, they have the highest number of heat-related death. And in 2022 data, you can see the baseline, how temperature rising, heat waves in Europe, heat waves in Indian subcontinents. We also facing lot of heat, lot of trees, fire, loss of due to heavy heat. Canada nowadays, no people watching the TV, no forest fire. can frequently happen. Brazil, Bolivia, Australia, United States. Simultaneously, one side you have a flood in Platte River in Plattsmouth, Oklahoma in USA, floods in Europe. Everything happened. So all are due to this climatic impacts. Every year, every month, we have uh, extreme events happened. Landward migration and loss of coastal area. Recently, what happened now? The sea level rise happened. Sediment load of river changed in the past 60 years, and sometimes increase in rainfall. Warming increase the evaporation, cloud result rainfall, increase in higher in subtropics and decrease in tropics and equatorial regions, like that. Ocean also a lot of changes, warm ocean, everything. Finally, we are all affected. So our lifestyle, we have to prevent our lifestyle. No, once environment carbon based from the carbon emission, climatic change and human health impact, change in temperature, change in precipitation, change in sea level, everything happen. Fisheries, agriculture, ecosystem, air quality, all will affect our human health. Heat strokes, rising temperature, exist a health condition, lot of diseases nowadays we are facing. No, mortality rate, fatal infant mortality, everything happened. Agricultural loss due to heavy temperature and sometimes more rainfall, sometimes drought, great loss of farmers. Cattle also depend upon the agricultural products, hence livestock will be affected. And entire vegetations, high latitude temperature increased 2 degrees centigrade. No, the vegetations decreased. Okay. Similarly, snow and ice melted, polar ice sheets, alpine glaciers, everything will be changed. Sea level rising. Again, see on satellite data, you can see the ice sheet 2022, and again it extended, melted. Sea level rise millimeter, 4.4 millimeter per year, like that. People are predicted. So if sea level rise, low lying areas are entirely affected. Even in Chennai, wherever the low lying area, easily it will affect. Similarly, Kerala, Kolkata, Surat, Mumbai. So for that only people, we want the carbon neutrality. That means balance between emitting carbon and absorbing carbon emission from the carbon sink. Simply eliminate all carbon emission together. Carbon sinks are any system that can absorb more carbon than they emit, such as forest, soil, and ocean. That's why every day, every school, every places, people talking about plant more trees, then we'll get a more carbon neutral. So carbon released to the atmosphere from the company activities is balanced by the equivalent amount by removed. We have a climate positive. That means active goes beyond the achieving the net zero carbon emission to create the environmental benefit by removing the additional carbon dioxide from the atmosphere. Zero emission. We are talking about zero emission. It is possible. It is impossible to generate zero emission, but we, we can approach to carbon neutral. Carbon neutral. Okay, we have to go for carbon neutrals. For that, what we have to do? These are all things we have to do. Save water, save energy, reduce the waste, adopt sustainable food system, reduce the e-waste, no to use single-use plastic, adopt healthy lifestyles. Lot of activities in their government: National Solar Mission, National Water Mission, National Sustainability, Green India Mission, renewable energy investment, electrical vehicles, carbon neutrality, sustainable chains, research developments. And individuals, what we have to do? Reduce the carbon footprint in your home, educate and awareness, plant the trees, waste reduce, adopt sustainability. How we see the nature and nature, how nature sees us. So we are all living in the nature. Okay. So Sweden is the best example. They introduced the carbon tax in 1991. The country reduced the emission by 25%, while maintaining the steady economic growth. They are all the powerful reminder of the sustainability and the precision that consist. United Nations also developed a system called carbon credit, to reduce the carbon dioxide gas emission. Okay. So by reducing our carbon footprint, one meal, one community, one purchase at a time, we collectively move towards a cleaner, greener planet. It's a time to step forward with intention and walk lightly for the sake of all life on the earth. Okay, this I already told. Impact, advantages, disadvantages, life cycles. Again, these are all covered in this. Life cycle studies focus on a single issues: recycling, greenhouse gas emission, climate change, carbon balance, and energy balance. And there is a standardized tool for conducting the multimedia cradle to grave assessment, ISO 1440 life cycle assessment, and I also uh, ISO 1414044 guidelines is there. Okay, so finally, I want to conclude. This life cycle assessment helps to quantify the environmental impacts. The ESG ensures the accountability and transparency. All together, we have a better sustainable business decision. So, this carbon footprint, the LCA and ESG, they are essential sustainability tool. They provide insight for reducing the environmental impacts. So it supports the industries, governments, and the communities in transitioning to sustainability, contribute to the achieve the global climatic goals. Thank you for your listening, even in this hectic time. That is from 5 to 6 o'clock. Thank you very much.
Thank you.
Any
Thank you.
doubt, clarification, you can please ask. I will give whatever I know.
Dear participants, you can ask your doubts. Or
Here,
otherwise, you can.
here we are working in our department. We are working for paleoclimatic studies. We are collecting sediment sample in the marine area. We are collecting the uh, undisturbed core sample using the mechanized boat, mechanized vessel like National Institute of Ocean Technology, NIOT, National Institute of Oceanography, Goa. They are providing the ship Sagar Kanya, Sagar Sampada vehicle. So we go into the ship and collected the undisturbed core sample. We studied the sedimentology, microfossil, and predict the past climate. What was the temperature? What was the paleo temperature, paleo monsoon, paleo ecology? Everything we studied and we interpreted. This type of study we are doing, and we also working on microfossils. How microfossils are affected our environment. So like the studies are also going. Apart from that, we are also working on heavy minerals. Wherever the beach side area, why we see a lot of color mineral, no, that mineral we have to estimate and evaluate. That type of studies also going on. And apart from that, we are working on groundwater studies. How groundwater polluted, how seawater intruded into the land area. Nowadays, major research is called submarine groundwater discharge. Nobody knows that. All of talking only the surface water. Most of the river water enter into the sea, but
Yes.
subsurface below the sea, there is a water is traveling.
Okay.
Below the sea, fresh water goes directly into the sea area. That is called
Hmm.
submarine groundwater discharge.
Hmm.
One of my students recently submitted her thesis in Kanyakumari coast. Water is traveling below the seashore.
Okay.
Okay, thank you. Any doubt? One or two
Any
questions.
doubts from audience? I have one doubt, sir.
Yes, madam.
Many organizations talk about reducing their carbon footprint, but measurement methods vary widely.
Yeah,
In
yeah, yeah.
your experience, what are the most reliable and practical approaches to calculate carbon footprints across different industries?
Actually, one measurement is there, but I don't know exactly that measurement. But in industrial area, mining people, no, they are all coming for environmental clearance purpose. No, that time
Mm.
they have cut all the trees and other digging the uh, place. No, so they have to calculate the area, how much area
Yes. Mm.
they are disturbed. So
Mm.
equivalently, they have plant the trees, so
Okay.
that way they have to balance it. So whatever they were removing from the earth, no, so
Mm.
disturbed, equivalently they have calculate the carbon emission. They have to calculate based on
Mm.
the carbon emission. Suppose one tree gives this much of absorb the carbon, like that they have to calculate. Suppose 100 trees they cut means they have to plant 500 trees.
Okay.
Like that, there is one calculation method is there, but I will tell you afterwards. But
Yes.
only with the help of how much damage they done, how much they will give back
Okay.
in mining sector. Similarly, industrial or building construction, like that they are doing same method.
Okay, sir.
Only thing is planting the tree. We have
Okay,
to
that is the main
if you
remedy.
plant more trees, we have to reduce the carbon emissions.
Okay, sir.
So particularly in the mining sector, why?
Okay.
Because they are entirely disturbed the land. They are digging
Yes.
the earth
Yes,
up to
yes.
40-meter depth, 50-meter depth. They are collecting the gravel sand, sand, granite, everything.
Yes. Yes, sir.
Even in a hilly area also they have disturbed. So automatically water level reduced, and for that they are doing for recharge. So like that, whatever they disturbed, they have give the remedy also.
Yes.
So they have to converted for environmental satisfaction.
Okay. So, what
Yes.
are the major challenges in standardizing LCA, that is life scale assessment studies, given differences in data availability, geographical context, and system boundaries, sir?
Yeah, there is a lot of challenges also there, madam. Lifestyle
Mm.
assessment, lot of
Mm.
challenges is there. Um, yeah, that is also depending upon the environmental factors.
Okay.
Mainly they depend upon environmental factor only. This lifestyles will be changed.
Mm. Sir, as the countries push towards the net zero targets, no, nowadays we are talking about net zero target.
Yes, madam. Yes, madam.
Do you think the carbon footprinting and LCA will become mandatory in regulatory compliances?
Yeah, that is good only.
Mm.
Like fossil fuel reduction.
Mm.
Once we did continuously like these aspects,
Mm.
definitely we'll go for net zero reductions.
Okay.
Lot of governance metrics also there. That we will do, madam. That is possible only.
Okay, sir.
Yeah.
From your perspective, which Indian countries are leading in, which Indian industries are leading in adopting ESG environmental, so social, and then governance frameworks, and which one need urgent attention, sir?
Mm. The energy sector only, mainly the energy industries. We have
Mm.
to. Uh, they are doing well, I think. Energy sector doing well.
Mm.
But I don't know which one is attention. Give for
Urgent
attention. Urgent
attention.
need is there, but energy sector people are doing perfectly.
ESG. Okay.
ESG is there.
Frameworks.
Yes, madam. Yes,
You are clearing all the
like
doubts.
renewable energy resources.
Yes.
No, they are doing correct way.
Um,
Yes,
Sir,
madam.
one question, sir.
Yes, madam.
Sir, myself, Anita,
Mm.
Triple Department. Sir, for our engineering student, can you suggest any research area
Mm.
for doing this and all?
Yeah. Very good question, madam.
Then we will
Uh,
suggest no. For a generic, so we are going to give the project to our student for our area only.
yeah.
We have to little bit change. We have a mindset to help our society also. So at that time, we are not in that area, no, in that US area.
Yeah, you have to do climate and health. Like that research is nowadays going on. Climate and health related work. You are in civil law, which department, madam? Which
Unfortunately, electric, sir, no,
elect
sir. I am in electrical.
No issue. In electrical and environmental, you have to go for electrical and environmental aspects. Research is there.
Yes, sir. Yes, sir.
Electrical environmental research is there. And nowadays, what happened? No, physics people they are doing with the geology people like radioactivity minerals like uranium, thorium, potassium, radon mineral is there. No, they are collecting from the sediment sample how much it affected radiation coming from the sediments, how it is affect the people. So like that, physics people doing this radioactivity studies, chemistry people working with the mineral studies, some mineralogy, using the spectroscopic instrument and other instrument, FTR instrument. They are studying with the help of geology and chemistry. Like that, civil engineering people also working lot of work in interdisciplinary with the geology, like river sediments, microplastics, like that collaborations. But you are in electrical department. No, I have to think over that. I will
Okay,
think
sir.
over that and I will give you the
So
answer
which one is
afterwards.
first area? We have to move electrical point of view into
Yeah,
that. That's
yeah,
it.
yeah, sure.
For calculation, any prediction,
Yeah.
any
Yes, madam. Yes, madam.
first area you told, no?
Yeah.
That's right. Okay, sir. Thank you.
Okay,
Sir.
thank you.
Any other questions from participants? Please raise your hand. You will be given mic.
Actually, that one more data I also saw. No? The Council on Energy and Environment and Water, they said the policies for India, power, residential and transport sectors, already they have saved 440 million tons of carbon dioxide
Okay.
between last 5 years. So that means they have to reduction in coal-based power generation, like that, reduce the carbon dioxide levels. That is going on.
Any other
Yes.
questions, please? Participants? Is there any question in the chat box?
Okay, madam.
I think there is no questions.
Why? Because now we are going to start feedback, exam, validatory, continuous. No, they are preparing their mind in how to write exam. What
Definitely,
are
sure,
the
sir.
questions you are to
And
going?
also from
Yeah,
2 p.m. onwards, they are fully engaged, no?
yeah. Whole day
That's,
sitting in the system. No, that is very difficult. I know the
yes,
situation.
yes,
We
sir.
also conducted this refresher course through online
Oh, mm.
for 14 days. No,
Mm.
same thing happened.
Very nice, sir. In your busy schedule, you
Oh,
just
no,
came
no
and
problem.
attended, sir.
No
I am
issue,
very
madam.
thankful to you. Mm.
Yes, no issue. I am also state environmental appraisal committee member. That's why I am telling this. I
Okay.
am only giving the environmental clearance for
Ah,
mining,
super, sir. Super.
mining of
Very
sand,
nice.
mining of the granites, everything. No, that
Mm.
that is going on.
Nice to hear you, sir.
For that, we concentrate on water pollution, air pollution, land pollution,
Okay, okay.
disaster management plan, whether they are
Mm.
doing correctly or wrongly. So then only we are going for environmental clearance.
Super,
Yes,
sir.
thank you, madam. Thank you. Anisha, madam, also thank you.
Thank you, sir.
Thank you.
Now, as we come to the conclusion of this enlightening session, it is my pleasant duty to propose the thanks. First and foremost, I extend our heartfelt gratitude to Dr. M. Suresh Gandhi for delivering such an informative and thought provoking lecture. Sir, your insights on sustainability, carbon footprint reduction, and lifestyle assessment have certainly broadened our understanding of the challenges and opportunities in building a sustainable future. A special thanks goes to all the participants, scholars, and colleagues whose active engagement has made this event meaningful. Finally, I wish that the discussions from today inspire all of us to adopt sustainable practices in our research institutions and everyday life. Thank you, one and all. Thank you.
Thank you, madam. Thank you.
This is the time for photo session. Please, all the participants,